In this lesson, we're going to discuss software-defined storage. Software-defined storage, also known as SDS, is a type of storage architecture that separates the management and storage of resources from the underlying hardware. This allows for more flexibility and scalability in storage management, as well as cost savings as it allows for the use of commodity hardware instead of specialized storage arrays. Now, software-defined storage is a new approach to managing storage that uses a policy-based approach instead of proprietary hardware and decentralized storage management. This allows for the aggregation of storage capacity across multiple technologies and provides storage in a non-proprietary form so that it becomes highly scalable. With software-defined storage, administrators can define storage configurations and policies and apply them to storage for the purpose of scaling capacity or for managing your costs. This results in an automated, more flexible storage management system that can then support different file, block, and object storage types. One example of a cloud-based software-defined storage system is Amazon's S3 service. It offers automated management, including storage scaling, a standard management interface through APIs, a virtualized data path for storing block, file, and object data structures, as well as scalable and flexible management of storage capacity, and the ability to view available storage resources across all of your technologies. Software-defined storage can also be used throughout the Amazon Elastic File System, or EFS, and the Amazon Elastic Block Store, or EBS. EFS is a fully managed cloud-native file system that allows users to easily store, share, and access files across multiple instances. EBS, or the Elastic Block Store, on the other hand, is a block-level storage service that allows users to create storage volumes that can be attached to Amazon Elastic Compute Cloud, or EC2 instances. Both EFS and EBS use software-defined storage to abstract the underlying hardware and provide the end users with a higher level of flexibility and scalability. Now, some of the benefits of using software-defined storage include the ability to support multiple types of storage hardware, such as flash drives, solid-state devices, virtual disks, and cloud-based storage. Software-defined storage is also very cost-efficient because it allows for scaling outward instead of scaling up, and this offers automated scaling without administrative intervention too. Software-defined storage can also provide a flexible and efficient way to manage storage resources and make the most of your existing hardware and cloud storage. For example, AWS allows the use of low-cost commodity hardware that can result in significant cost savings, especially for large-scale storage environments. Additionally, both EFS and EBS are fully managed services, which means that Amazon Web Services is going to handle all the underlying infrastructure management for you and allows your users to focus on their applications instead. In Microsoft Azure, software-defined storage can be used through Azure Files and Azure Disks. Azure Files is a fully managed cloud-native file service that allows users to easily store, share, and access files across multiple instances. Azure Disks, on the other hand, is a block-level storage service that allows users to create storage volumes that can be attached to Azure virtual machines. Both Azure Files and Azure Disks are going to use software-defined storage to help abstract the underlying hardware and provide your users with a higher level of flexibility and scalability. Now, if you're using GCP or the Google Cloud Platform, software-defined storage can also be used here by using Google Cloud File Store and Google Persistent Disk. Google Cloud File Store is a fully managed file storage service that allows users to easily store, share, and access files across multiple instances. A Google Persistent Disk, on the other hand, is a block-level storage service that allows users to create storage volumes that can be attached to Google Compute Engine instances. Both Google Cloud File Store and Google Persistent Disk use software-defined storage to abstract that underlying hardware and provide the users with a higher level of flexibility and scalability, just like the other systems we've talked about. Now, one of the main advantages of using software-defined storage inside AWS, Azure, and GCP is that it allows for the use of low-cost commodity hardware, as well as allowing these storage services to be fully managed and provide high availability and scalability. Now, one of the biggest disadvantages of using software-defined storage is that it can be difficult to predict the performance of storage volumes, especially when you're working with large amounts of data. Additionally, users may have limited control over the underlying hardware because it's been abstracted, and this can make it more difficult to optimize performance for specific types of workloads. So remember, when it comes to software-defined storage, or SDS, this is referring to the type of storage architecture that separates the management of storage resources from the underlying hardware to provide more flexibility and scalability in storage management resources than would be available in a traditional on-premise type of storage system.